Yeah, thanks everyone for having me. I'm from Brighton originally, but I've since moved up to London, so it's nice to be back in Brighton, even though it's just virtually. So tonight we're going to have a look at tools for working with Excel in Java, and I'm going to show you a few examples of that. Now, Excel, as you know, is something that is used in every industry for countless different tasks. But I'm going to show you that Java and Excel can actually work like side by side really nicely. And I think we'll see that it's going to be a lot easier than you might think. So to quickly introduce myself, I'm Tony Roberts. I worked in finance as a developer for many years, both on the buy side for hedge funds and on the sell side for larger banks as well. And as some of you might know, that's an industry that pretty much runs on spreadsheets. A few years back, I launched a product called Jinx, and that's for developers to write Excel add-ins using, well, Java, but also any JVM language. And we'll take a look at that a little bit later in this talk. I wanted to start off by just kind of asking the question, like, why Excel? Because I know to developers, it's often quite a kind of a scary topic, and people tend to dismiss Excel as something that they don't really need to care about, because there's other tools for doing data management or data analysis and that kind of stuff. So many people will be thinking like, why do I need to care about Excel? Also, something I come across quite often is when I speak to developers about Excel, they'll always have horror stories about using Excel in the past. So whether it's having to maintain or manage like overly complex spreadsheets using loads of like nested formulas and loads of complex VBA, or whether it's just where you've got in my case working in finance, it was often a trader would be like, why is this spreadsheet blowing up, and you find you're having to debug, wading into huge swathes of VBA that are just like atrocious. So I think it has a bit of a reputation as being something that's really, really hard to maintain and support, and I think that's partly the reason why developers tend to be very kind of anti-Excel. But again, like I said a second ago, we're going to show how it doesn't have to be like that. We can engage with Excel as developers and make a tool that works for us as developers, but also delivers value to end users. Because really, I guess the point of Excel is kind of it's not built primarily for developers, but it's built for non-developers who need to work with data. So for us, that's like business users in whatever industry we're in. There's always people there working in Excel. I remember when I first started working in finance, one of the first applications I developed, it was for a trading desk, and I was really proud of this application that I built, and I demoed it to this group of traders. And literally, like, the very first question I got asked was, how do I export this to Excel? And so, that for me really illustrated this point of, like, as developers, we want to build applications and we want to do like all kind of fancy stuff. But as a business user, really what they want is they've got some job to do. They know how to use Excel. They're using it anyway, and they want tools that are going to help them, support them do their job in Excel. So really, to follow on from that, I guess the way that I think of my job as a developer, and the way I think a lot of us should be thinking of our jobs, is that really what we're there for is to support the business and to help the business succeed. And whether you're a solopreneur or a part of a multi-billion-dollar organization, software is the enabler that makes everything else work. So it's not really, software isn't the end goal in itself. It's what allows the business to function, and we kind of need to bear that in mind when we're trying to support our business users. So with that in mind, I'm not going to really try and convince you that you need to start using Excel yourself in your day-to-day job. But if you take a higher level view of what you're doing, you'll probably realize that there are many other people around you who are already using Excel, and part of our job is to provide them with the tool to do their job. So with that in mind, if the users are productive and comfortable working in Excel, then going about building a complete replacement for what they already have isn't necessarily going to be the quickest or most cost-effective thing to do. And ultimately, it doesn't guarantee that they won't continue to use Excel behind your back anyway. So I think the question we kind of need to ask ourselves is, how can we best help our users, given the assumption that they really would prefer to continue to work in Excel anyway? And there's a few different options, and we'll explore those kind of in the next part of this talk. But they're basically, first of all, we can output static Excel reports. Secondly, we can automate Excel. So, for example, if there's some repetitive task, we can write macros and things to automate that. And then thirdly, we can extend the functionality of Excel, and that's one of the more interesting things where we can start to integrate our own software into Excel, and we'll come into that in a bit more detail. So, first thing I mentioned there was writing static Excel reports, and a lot of you will be familiar with this already. So the advantages of that are, we can give users a report that they can just double click and open, but we can save time by reformatting these reports compared to just giving them a CSV report. So I imagine many people watching this will have already written some stuff to get some data out of the database, do some calculations, do a report, that kind of stuff, and then very quickly write it out as a CSV file. So we save out to CSV file, throw it across the wall at someone who's going to have to do some more stuff with that, and then we're like, yeah, job done. So just for a second, imagine that part of your job was to take that CSV report, open it up in Excel, do some secondary calculations, do some reformatting, get some summary level results, that kind of stuff. Or maybe we need to take the data from the CSV file and munge it into a report for higher level management. And that's actually, it sounds like quite simple, but it's a very simple way of describing what a lot of people do, spend a lot of time doing. So rather than have them have to do all of that manual work every time, if we just put a little bit of work into the development effort to give them something that's kind of more closer to the final state that they want, then we get them that bit closer to spending a bit less time doing this very manual, very tedious stuff. And you can kind of imagine if you were doing that manual, tedious stuff every day, just taking a CSV file, formatting it, shuffling it around or whatever, you'd be very tempted to write some VBA macros to help you do that. And then we end up very quickly in that situation where you've got a nest of VBA, which is horrendous to maintain, and everyone goes, oh my God, Excel sucks. So that's really what we're trying to avoid. A few other things with writing CSV reports, writing Excel reports, is we can not only have the formatting, but we can also include multiple sheets, so we can make the more complex documents. And finally, we can also include formulas for basic calculations. So, for example, if you had some kind of report where you got a whole load of data, but then the users might need to input some data as well, we can include formulas so that they can have something more like a dynamic report, but obviously still quite limited because we're just using basic formulas. Finally, if you really want to go nuts, you can add charts and formatting and things like that. So turns out that to do all this stuff, there's a really good a really good Java package that lets us do all of these things called Apache Poi. For those of you that have worked with Excel already, you've more than likely come across this. And I just want to jump out of PowerPoint now and get into a demo because it's kind of a bit more fun. So I'm not going to spend too much time looking at Poi, but just to give you kind of an idea of what you can do with it. What I've got here is some pretty simple code that's just really meant to mock up what we might do in a real application. So just delete this file. In this input CSV file, I've just got some sample data. So you can imagine that this will be like what I'm reading from a database or some report that I'm producing in Java. And then very simply, I can create a workbook object in Java, create a sheet, and then write some data to it. So in this, write basic report data, all I'm doing here is creating a row, setting some cell values, and then iterating through those records, which I'm loading from that CSV file, and writing them to the Excel sheet. So if I run this, there we go. That's now produced this output XLSX file. And if I double click that and load that, then I've got it in Excel now. So, this is where a user might go in, they might start highlighting these things, formatting things. Really, like as it stands right now, we haven't given them anything that they wouldn't have got from a CSV file. So we can do a bit better than this. So we can also go in, let me just comment this bit out. And instead of creating just a plain sheet, we could write a formatted report. And what you'll see here in this method is that I'm doing basically exactly the same as I was in the last one, where I'm using this create cell thing to write the data, but I'm also on each cell setting a cell style. So further up here, there's a whole API. I'm not going to go into the details too much, but just to give you like an idea of what you can do, you can create some cell styles and then apply those styles to some cells. So if I run this one now, then this new workbook is pretty much the same, but now we've got some better formatting, and you'll see I've added some sort of currency formatting to these ones and some percentage formatting and stuff like that. And you can imagine, like if you're having to go and do this formatting manually every day, then just a few lines of code in the script that's producing the report could save a huge amount of time. Finally, the last thing I mentioned on that previous slide was adding some formulas. So that was the last thing I wanted to show you here. And in this method, I'm doing the same thing while I'm writing that formatted report, but then for the last row, I'm actually then going to go and add some new formulas. So all this code will be online, so I'm not going to like go over each line. It's just really to give you an idea of what's possible. And if I run this now, what we'll see is this extra row that I added. It's the same formatting and everything, but now I've got these extra numbers here. And rather than just being fixed numbers, these are actually formulas in Excel. So hopefully you can see here, like this is actually the sum of these numbers. So if I, if I was going to change this, then this updates as well. So this can be like a really nice way if you imagine a sort of pre-canned report that a user might want, where they might have some bits of data, but then some cells left blank with some basic calculations in the sheet. So again, it's all about like saving the user a bit of time and getting them something that's more immediately useful to them as soon as they open the report. Let me just jump back into this. And because it's kind of what we've seen there is, writing Excel. Oh, I'm on the wrong there. There we go. So what we've seen in that example there is that we can write out Excel reports, and that's great, but there are still some limitations. So ultimately, we're still just giving the user something that's fairly static, and they might be able to request that a report gets rerun, whether that's like by emailing a developer saying, "Oh, can you rerun last night's batch report or whatever." So they don't really have like a huge amount of flexibility there. And Excel is a lot more than just a tool for viewing static reports. Really, if you kind of think about Excel a bit more broadly, it's an insanely flexible UI tool disguised as a spreadsheet. So traditionally, Excel is automated or scripted using VBA, and I think given that everyone on this call is Java or non-VBA developers, would all agree that writing huge enterprise-grade applications in VBA just isn't really possible. So just imagine for a moment that instead of writing VBA in a spreadsheet, we can actually do all of the same things that we could do in VBA, but using Java to control Excel. Now, Excel, as you know from VBA that it's scriptable, but it actually has a scriptable interface. So anything that we can do in VBA is also possible using this scriptable interface, which we can call from Java or from any other language. Slight pause before the next thing. So it's called COM. So there's probably a few people there being like, oh my God, COM, like what? If you've dealt with COM before, you may have misgivings about it. Because COM's it's a pretty ancient Microsoft technology, really. But despite its age, it's still widely used by Windows applications. And it has this kind of reputation of being difficult to work with. But I think most of that reputation stems from kind of the intricacies of dealing with COM interfaces from C and C++, which is where it was more traditionally used. But actually in Java, COM is much simpler to use than you may realize. If anyone's ever done any MFC or ATL programming in C or in C++, you may be having sort of nightmares about that stuff. But actually in Java, it's really much simpler. So once you've got over the shock of me using the term COM, then what you'll find is the entire XL VBA class model is exposed through that COM interface. What that means is that our Java code can interact with XL in exactly the same way and kind of just as easily as we could using VBA. So in order to use the COM interface from Java, we need a Java package to do that. And the one that I found works kind of most nicely is this com4j one. It's a pretty good package, but one of the complexities with it is you have to build some wrapper classes for the type library that you're using. And if you're not really that familiar with COM, then that can be a slight sort of hurdle to get over. So we have some pre-built com4j XL classes, which you can get from GitHub, from the XL Java organization. There's a Jinx com4j repo there. And with those, you can get started pretty quickly. So with that, I want to jump into another demo, just to kind of show you that it's not all as scary as you might think. So what I've got here is another example where there's not too much code here, but what we're doing on this very first line is using this com4j package to get an active object. Now, an active object is like that's our COM object. So in this case, we're getting the VBA application object, and using this XL Java com4j package with the main com4j stuff, we have this application class that's already defined. Now, this application, if I click into it, you'll see it's kind of it's pretty long and complicated. But this is really the wrapper between the underlying COM API and our Java. So we call this getActiveObject with tell it that we want it to come as this type, this application, and also give it this CLS ID or class ID. Now this is really just kind of like a fixed constant that you have to know in order to find this application object. But once you've got this thing, you can then interact with it in the same way as you can from VBA. So in this example here, what I'm going to do is say, get the selection from the XL object. If you've ever done any VBA, you will have done like, something .selection, which gives you the current selection and then set some values or whatever. But here we're saying, get the current selection. And then this query interface thing is, you can think of this as being like a cast in Java. The object that gets returned here is a generic COM object. And then this query interface is saying, get me the range interface from this object and return it as a range here. So range represents like a range of cells in Excel. And then here we're simply saying, set the value on the thing. So if in Excel, actually let me do these side by side. I select a range here and then run this code, what we should see, is I can actually, like, from my Java code, I can set the values in Excel. So what we could do is you could imagine having a Java application. So this could be like your desktop application that some business users using, and they want an export to Excel button, or they want, something to say, do some repetitive task in Excel. You can have a button in that application that uses this to call back into Excel, read values, get values, set whatever you want, but without using any VBA. So I was trying to think of some kind of nice use cases for this. And I guess my background in finance, what I came up with was a simple trade blotter. So kind of back in the day, traders used to phone up their counterparties, do some trades, and then write the trades down on a piece of paper. And this is literally like kind of how it still works in a lot of places. They'll have a pre-printed sheet saying, I traded this with this counterparty. At the end of the day, one of the desk assistants will take all of those up and then enter them into the system. These days, there's more pressure to have things entered directly into the system throughout the day. And people tend to have tools on their desktop where they might, do some entry as they do each trade. But the reality is the trader's still going to be sat there in front of Excel, doing their trades, deciding what they're going to trade, and then talking to someone on Bloomberg Best or whatever, looking at an Excel spreadsheet saying, yeah, this is what I want to trade. Then they have to copy that from Excel to something else. So what I wanted to show you here was kind of an example of what if we could bring that trade booking system into Excel. So rather than having to copy and paste from Excel to another system, they could just do it all in Excel. So this right trade blotter example here, I'll run it in a second, you'll see. Basically, it does nothing apart from get a range of cells, set some values on them. So if I run this here, you should see, yeah, so now it's just put these headers here. So this is really just telling the trader, enter your trades into these range. So if I said, okay, I traded this and I traded 100 of them and the price was 5, and then I traded something else, 50 of them, price was 10, this kind of thing. So they'd enter all their trades in here. Obviously, this is grossly simplified and you'd have more fields and what have you. But after you've done that, because we can both read and write from Excel, the next stage is I've got a method read trade blotter, which is going to read this whole range and do some processing on it. Actually, let me say, if here, like, let's say I've got a typo, like for whatever reason, I'm not allowing negative prices, but I've put a negative there. So if I run this, what this code will do is read this thing. It says this one's been booked. So that's to indicate that, this code will have gone off and written it to a database or submitted it to a message queue or something like that. Like it's gone on for further processing. It's now in the system. But this one, I'm getting some validation errors saying, actually, there was an error with this one. The price should be greater than 0. So this gives the trader some instant feedback rather than them doing all these trades, talking to their counterparties, and then having to go and book them in a system and then get some validation errors. Or worse, and this is something that I've seen quite often, is that traders will book something, but then they only get told that there was an error with it, like after someone else has looked at it the next day. Here we can kind of close that loop. They can then go in and fix that, hit run again, and then book it. So now we've seen, we've kind of got, we've still got two applications. We've got Excel on the right-hand side, and then this is mocking like our trading application, but just running some Python code on the left-hand side. But by integrating the two together, we can kind of do some, make things slightly nicer by giving a bit more integration between the two. So we're not just outputting a static report, or we're not just reading in like a file that's been saved. We're actually, doing stuff where we're calling into Excel from something else, and that can be like a really powerful way to improve your user's experience of applications that you're writing. So let's see. So I wanted to get onto writing Excel add-ins now, because so far we've seen writing some static reports, and we've seen having an external application talking to Excel, and those are great. And I think generally, like in the places where I've worked, if we had more things that work that way, then there'll be a lot of very, very grateful users. Excuse me, but I still think we can do way, way better. So if our users are already working in Excel, then kind of why make them come out of Excel and use an external application, export data or whatever, and then go back into Excel? Because that's, to me, it's just a lot of wasted time and a lot of opportunity for errors to creep in. And also, we're spending a lot of time building these custom applications, these like complex user interfaces or web apps or whatever. But it's not even what the user wants. Like, the user just wants to work in Excel anyway. So if we think to ourselves, like, what if we could actually build our application, or at least part of the application, to run right inside of Excel? And that's what I mean when I talk about Excel add-ins. So I'm not talking about writing loads of VBA glue code or anything like that. I'm talking about writing Excel add-ins entirely in Java. So using the same Java tools that we already use, and then deployed to users through Excel, but not strongly attached to any particular workbook like VBA. So we can still deploy our Java applications to the end user in the ways that we're already used to. So I kind of covered like most of these points on the previous slides, but in terms of writing an Excel add-in itself, it used to be that we had a couple of pretty limited choices. So Excel has a very low-level C API, or there's VBA, or there's some tools for doing some Excel add-in development in C#. And for a long time, certainly for sort of enterprise solutions, C# was kind of the least worst choice, because there was no good way to do it in any other language apart from C. So I've had quite a bit of experience with this. I actually launched a company about 10 years ago called PyXLL, and that's a tool for building Excel add-ins, but in Python. And in banks in particular, like, Python was an up-and-coming language, and so it kind of made sense to use Python as this way to write very quickly put together Excel add-ins, but deployed to end users without needing any VBA. And then more recently, maybe like 2 or 3 years ago, I was talking to other groups of people who were doing similar things, but in Java, and they told me about the difficulties that they'd had trying to bridge Java and Excel. And I did some research and kind of realized that there wasn't really any way to write Excel add-ins in Java. So I thought it'd be good to try and fix that. And so that's when I wrote Jinx, which is Jinx of Java in Excel. And it basically lets you do everything that you could do writing an Excel add-in in C, but in Java. So it means you can write worksheet functions. So that's where you do like equals, your function name, something, blah, blah, blah. Real-time data, streaming in like real-time ticking prices, or whatever it is, directly into Excel. Write macros and menus and ribbons and all this kind of stuff. Dynamic array functions were like a new addition in a recent version of Excel, where you can have arrays that automatically expand. So Jinx supports that, not just in the latest Excel, but way back in like Excel 2003. And another interesting thing is being able to pass Java objects between Excel functions, and I'll show you that in a second as well. Jump back into a demo. Let's see. So first of all, I should just grab a browser. So if you're interested in this, then obviously I'll give you my contact details and stuff at the end of the talk. But if you go to exceljava.com, you'll find the Jinx product with a whole load of documentation about it and everything. And there's also a download page, so you can go and download it and give it a go. And then there's tutorials about getting started with Java, and then also Scala, Kotlin, and Clojure, along with a user guide, and there's some Java docs as well. But essentially what you get when you download Jinx is an Excel add-in. So an Excel add-in is a .xll file, and then you add that. It's a bit bigger. You add it in your add-in section. So you just like browse for it and add the Jinx add-in. And also in the download is a config file. So this jinx.ini file, and this is where you configure the add-in and tell it what to do. What it's actually doing is embedding the JVM runtime into the Excel process, and then it's dynamically loading some classes off the class path and loading some classes and doing a bunch of things. And we'll see how to use that in a second. But it's really kind of that simple to configure. And you can tell it what JRE to use. So it works with all JREs from Java 6 onwards, and you can just configure that to point it to whichever one you want, or use the system default. One of the main things that people use Excel add-ins for is for adding what I call user-defined functions, or UDFs. So in Excel, like a typical function would be something like, if I go onto here where I do equals and I say sum, these things, nothing amazing here. But this sum is an example of an Excel function. And what we'll see with Jinx is how to add user-defined functions. In this demo, what I've got is just a simple public class called Excel functions. And then in another config file here, I've listed this Excel functions class. So this is telling the Jinx add-in that when it starts up to load this class. And then on this class, if I add a simple function, let's do something a bit different from the example I've got down here. Let's call it Java tests. Whatever it is, and then just say, just times them together, something like that. So obviously a very, very simple static Java method here. But if I wanted to make this into a UDF, all I have to do is add the Excel function annotation, and that's it. So in here, just to show you, if I do equals Java test, that function doesn't exist. But if I build this now, so this is rebuilding this jar that I've got set up in this project, and then hit this reload button in the ribbon. Now, I've now got this Java test function. So if I say, 5 times 10, 50. So that's actually calling my Java method here, but directly from Excel. We can do things like, I'm using IntelliJ, but you could use Eclipse or whatever. In my jinx.ini file, I had the Java options set up to talk to the Java debugger. And if I start the IntelliJ debugger here, actually, let me. Then here, when I've called into this, I'm now debugging straight into my Java code. So you can see kind of Excel stopped because I'm in my debugger. I can see the variables, I can step through and do everything. So it means that in terms of actually developing an Excel add-in, it's super quick because my sort of iteration time is minimal. So here I could add another argument there. Build the jar again. Reload this. And then now you see this Java test function has now got this third argument. And here we are back in the code again. So my kind of the, this iteration cycle of being able to, write the code, build it and debug it is super, super slick. Obviously, this is a pretty trivial example. Again, going back to finance, an example of something that's maybe a bit more useful is this Black-Scholes function here. It might not mean much to people outside of finance, but what this is just it's a mathematical function for calculating the value of an equity option. So you can see it's some fairly vanilla Java code here, but again, just decorated with this Excel function. And I think, oh yeah, I did have a bit of workbook saved here. So here what I've got is a bunch of inputs, so matching my inputs to this function here of spot, strike, blah, blah, blah. And then here, this value thing is calling this Black-Scholes function. So actually, if I put a breakpoint in here, we can see here I'm going to my Black-Scholes function, and I can step through like I would normally, debug it and everything, but also see the value here. And this is kind of nice because what we've done is taken a simple function that we'd written in Java, but then we can expose that to a user really, really quickly. So rather than having to write a web app or something where the user can go in and put some values, we've given them like a simple tool which they can then use to build their own dashboards or their own calculation sheets or something like that. So this thing here is just calculating the theoretical value of a portfolio of options and then just charting them beneath, but all because we've been able to give them this simple function in Excel. So, you know, for example, I might want to say, how does this chart look if I change it from a call option to a put option? Let's get rid of this breakpoint. And then, you know, very quickly recalculate to change that, or say, well, what happens if I make it reduce the volatility to 5? You can see it's this corner's just becoming a bit sharper. If I increase the volatility, it becomes a lot rounder. So this kind of functionality is something which we could obviously build like a web app or a desktop application to do this kind of calculation. But if you're in an environment where the requirements are changing a lot, or you know, you need more flexibility, then actually exposing these things as small little tools to Excel can be amazingly powerful. Oh, I mentioned as well that we can pass like Java objects between functions. So I just wanted to show that like super quickly. And I've got this Black-Scholes function too, which is taking a market data object rather than, so this one here is taking very normal vanilla data types, which we can easily see how they map from Excel to Java. But here we've got this market data object, which is a more complex Java object. So I wanted to show how that maps from Excel to Java. Now, I've also got in here, where was it? Oh yeah, sorry, here I had a load market data function. And what this is going to do is load, I've just got like a mock, kind of a mock object of this here, just to show what would happen, whereas this would be going off to a database and getting a load of stuff. But if I say load market data, this will call this and return this market data object. And in Excel, what it looks like is this kind of weird string. So this weird string is actually a handle to the real Java object that we've just returned. And I can pass that handle into another function, and it'll automatically retrieve that. So you can imagine this could be loading market data for a particular date, for a particular market, you know, all this kind of stuff. And then the user might say, okay, well, now I want to price, using my Black-Scholes 2 model, I want to price an option using this market data with a ticker XYZ, just because that's the ticker that I used in my mock one here. And with a strike of 200, years to expiry 5, is called true. If I call that here, if I put a breakpoint in, what we'll see is that actually what's being passed in here is this market data object, which I returned from Excel here. So I've created a Java object, returned it to Excel, passed it into another Excel function here. By the time it comes back into Java, I've now got this Java object that's come all the way through here. So it's kind of means that we can build up much more kind of rich functionality without having to exploit everything to Excel. And a really kind of powerful case for doing this is where we have large arrays of data. So if you had an object that represented like, you know, millions of rows of data, like potentially the market data object could, you can have it represented as a single cell in Excel rather than a table with like a million rows. Oh, actually, So I think I'm going to finish pretty soon, but there's just one final thing I wanted to show before we end, which is going back to that report that we had when I was using the com stuff, that thing where I had a trade blotter, and to show you how you can have, rather than have a completely separate application that just talks to Excel, how you can integrate it with Excel itself. We saw this ribbon object before where I used the reload button when I rebuilt the jar file, but actually this ribbon is just defined by some XML. So this XML is here, and if I go and edit this, add a new group to this tab here with a couple of buttons, create trade blotter and book trades. If I rebuild this jar file again, and then reload this, we'll see that instantly I've now got these new buttons in my ribbon, and these buttons relate to actions that I've built. So here I've got write trade blotter and read trade blotter. These are in this class here, but this time using this Excel action annotation. And this is what links these buttons to these Java classes. So this is exactly the same code that we looked at before, where this write trade blotter is literally just copied and pasted. But if I run it from here, then we get the same thing that we got before, where I can say A, B, whatever it is. And then once I finish doing that, I can just click book trades, and I get the same behavior that I got before. But this time, rather than having to go to an external application, I've now just integrated that right into Excel. So we can do things by adding it to the ribbon. We can add buttons to the worksheet. Literally, anything that that previously we might have done in VBA or building an add-in using a different language, but just by building a jar in Java, deployed to the desktop, but running in Excel. I think, let me go back to PowerPoint. There's a couple more things I was going to show, but I want to leave time for some questions. So just go back into this. So just kind of to recap, I guess my main message that I want you to take away is that developing for Excel is not painful. There's loads of different options, from static reports to automating Excel with com to writing full Excel add-ins. So if you're working for a business where people are using Excel, or maybe even yourself, if you're not developing all the time, sometimes you're doing data analysis or data exploration, you can build toolkits of Excel functionality, but without having to go down the road of getting too wound up in VBA. So with that, that's kind of all I wanted to talk about. I hope I haven't rushed through things too quickly. The code is actually on GitHub here. If you go to the Excel Java thing, you'll find it. It's based on some code that I used for the LJC earlier this year. But this code is pretty up to date. Again, go to exceljava.com to download Jinx if you're interested and have a play around with it. And please, do reach out by email. It's just totally at exceljava.com with questions. I'd love to hear what you think.